Okay, here we go. Here is lesson 2 in chapter 11. And since we're kind of moving ahead here, this is actually 11.4 in the purple book. Okay? The title is Multiplying and Dividing Rational Expressions, and this is from your example pack. Now, multiplying and dividing them will follow the same rules as multiplying and dividing fractions, okay? So we know that we multiply across numerators and multiply across denominators. So we would get, for this first example, A, 3 times 4 all over x times x squared. So you're going to have to use your exponent rules for some of these. So 3 times 4 is 12. And x times x squared, remember we add the exponents, so we would get x cubed. All right. There we go. And again, with these, because we have variables in the denominator, there would be excluded values. You would have to understand that for this problem, looking at the original problem, you could not have x equal to 0, okay? Let's look at B. So for B, we are going to multiply across, and we'll get x times x minus 3, and that will be over x plus 4 times x minus 2, okay? We look for anything that can cancel, okay? Is there anything that we can cancel out of this? In the denominator, you have two expressions, x plus 4 and x minus 2. The numerator expression is x minus 3. We cannot cancel out any of the x's because we cannot factor out an x in any of the denominators. So again, excluded values would be a -4 and a +2. But this is actually the product, and it cannot be simplified anymore. So always look to see if it can be simplified. And in this case, it cannot. So, okay, sorry about that. Just wanted to erase that extra. Okay, so then if we get to the try it section, so we would want to multiply 6 times the -2, and in the denominator, a squared times a cubed. 6 times -2 is -12, so the whole thing would be negative. And a squared times a cubed, we would add the exponents, and it would be a to the 5th power with nothing to cancel. Again, a could not be equal to 0. On to the next one. In the numerator, x minus 5 times x minus 7 all over our x times x plus 3. I just went ahead and rearranged the order of the monomials or the polynomial on the bottom because it's just easier to show that x in front of the parenthesis instead of behind it. Again, nothing to simplify. We can't factor out an x in the numerator. So if we were thinking of excluded values, we would not want a -3 and we would not want a 0. But this is our final answer. Okay, so sometimes we can simplify, sometimes not. And that's what we'll be looking for. So the next example, we will be doing some simplification. So I'm going to clear these. If you need to pause them and write them down, now would be the time. All right. So example 2. In example 2, again, we're going to multiply numerators and multiply denominators. The first thing I do notice that I want to do, I'm noticing now in the denominator of the second fraction or expression that there's a difference of 2 squares, okay? So because the first part, 4x squared, is a perfect square, and minus 1, which is another perfect square. So let's rewrite that. So we have 2x plus 1 all over 3 times 6x over, and then the difference of two squares will be 2x minus 1 and 2x plus 1. Now, before we go ahead and multiply these out, remember when you learned about multiplying fractions that you could simplify using cross cancellation. So we're going to look for things that we can cross cancel, and I see the expression 2x plus 1 in the numerator of the first fraction and 2x plus 1 in the denominator as a factor in the bottom. Okay, so I can cancel. That just cancels completely out. That's a fraction equal to 1. The other thing I can look for is, because I would be taking 3 times the 2x minus 1 and I have 6 times x, I can cancel out a 3 from the 3 and the 6. So 3 divided by 3 is 1 and 6 divided by 3 is 2. So I have canceled that out to get a simplified answer that looks like this. 2x over 2x minus 1. Okay, so by simplifying before multiplying, it makes it a lot easier. And again, on all of these, if you want to, pause the video and do the try it before I explain it. Okay, looking at the next one. Couple things that I see going on. One, in the second fractional expression, I see that I can factor out a -8 in the numerator, and I have another difference of two squares in the denominator. So I'll write the problem. I'll keep the first one. There's nothing that I can factor out here. Okay, but I can factor out a -8, which will leave me with x, and -16 divided by -8 is a +2, so that becomes +2. My denominator then, when I have a perfect square in x squared and a perfect square in 4, difference of two squares, I'll have x minus 2 times x plus 2. Okay, and by looking at this, we know that if we had to tell about the excluded values, it would be x could not equal 0, could not equal 2, and could not equal -2. Okay, now before I multiply, I can go ahead and start cross-canceling. I see the expression x minus 2. I can cancel. Those are equal to a fraction equal to 1. This 8 and this 8 change into 1s, okay? This x plus 2 will cancel with this x plus 2. So what do I have left? I have, when I cancel these, this whole expression here becomes 1. These become 1. This becomes 1. This becomes 1, because that's what I'm canceling out. Our fractions equal to 1. So I have a numerator of 1, but it's also -1. So I have -1, and the only thing left in the denominator that I did not cancel out is this factor of x. So a -1 over x. Okay, so in example 3, sometimes you will see it written like this over 1. Sometimes you will just see the first expression, 3s plus 2 over 2x plus 4 times, and then you'll have your trinomial. Remember that if you see anything written just times this or divided by this, you always want to make it a fraction over 1. So I went ahead and did that. I put the fraction over 1. So we're going to look at the first one. 3 and 2 do not have any common factors, but 2 and 4 do. So I can definitely factor out a 2 in the denominator. And of course I will factor the trinomial. So let's go ahead and do that. So I'll keep the 3s plus 2. If I factor out a 2, I'll get s plus 2. If I factor, I'm looking for factors of 6 that will sum to 5, and I know that that's going to be, make sure that you know that that's multiplying. Sometimes my dots are a little bit. So I'll have s plus 3 times s plus 5, and all that over 1, okay? Now I have, oh goodness, why did I do that? I don't even know why I did that. I think because they sum to 5. Who knows? Who even knows? Who really knows the answer to that? Okay, but I hope that that threw up an alarm bell for you. So I have, could be too that this S looks like a 5. Goodness sake. This virtual learning stuff. Okay. So 3s plus 2 over 2 times s plus 2 times the factor of s plus 2 times s plus 3. And again, it doesn't matter the order that the factors are in, right? Because I could have, you know, s plus 2 times s plus 3 or s plus 3 times s plus 2. The whole thing would still equal that other trinomial. When I look at things to cancel, the only one that I have is the factor of s plus 2. So this and this cancel, okay? So now I'm going to multiply the numerators together. So I will get 3s plus 2, and that'll be times s plus 3. And then in the denominator, I will have a 2, because 2 times 1. One thing that you'll have to play around with, and I'll give you several checks on Google, on Big Ideas. I'm not sure really if they're going to have you go ahead and FOIL the two binomials on the top and give your answer in the form of a trinomial. A lot of times they just go ahead and let you leave it like this. That would be a good way to, and a reason to show your work on paper, because if for some reason it's counting it wrong on Big Ideas, I can go back and look at your work. So make sure you're circling your answers and making it very clear which work goes with which problem, so I can give you the credit back where it's deserved, because I would be fine with you giving the answer like this and not having to go ahead and FOIL. All right, so go ahead and pause if you need to write things down. I'm going to clear it out so we can try a few more examples. Okay. Okay, for this next one, then we will want to multiply. So of course we're going to first start by factoring the numerator of the second fraction. So we'll have 2v over v plus 3 times, and then the factored form. So we're looking for a negative 15 factors of negative 15 that sum to a negative 2. So I'm thinking that's going to be negative 5 and positive 3. So I'll have v minus 5 times v minus 3, and all that over 1. Okay, to cross cancel before we go ahead and multiply, I have this expression v plus 3 as a factor, and this one that's v plus 3. Notice that we had to have a negative 5 times a positive 3 to be negative 15, and negative 5 plus 3. So you may have already seen my little error of omission. I think I tried to draw it and it just didn't copy. Who even knows at this point? All right, so I will cancel it so that my final answer becomes the expression 2v times v minus 5. All right. In the next example, example 4, we are now switching to division. So notice the division sign. When we divide, the algorithm is for us to take the reciprocal of the divisor and multiply. So we need the whole keep, change, flip. So the second expression is the divisor, dividend divisor. So we would want to rewrite it first as a multiplication. So you have your a squared plus 7a plus 10 all over a minus 6, and then we're going to multiply by the reciprocal of the second. So we'll have this difference of 2 squares in the numerator and a plus 5 in the denominator. All right, So we'll want to start by factoring both numerators. So we're looking for factors of 10 that will sum to 7, and I believe they're both positive, 5 and 2. So I'll start back over here, and I have a plus 5 times a plus 2, and that's all over the a minus 6. I'm still multiplying. It's hard for me to get my little multiplication dot to show up. And then a difference of 2 squares pattern, right? You have a square for the first term and a square for the second term. So we will have a plus 6 times a minus 6. All over the a plus 5. Now cross cancel. We see a plus 5 here and here, ching ching, and a minus 6 here and here. So we're left with a plus 2 times a plus 6. And again, I'm perfectly fine with your answers being in factored form, but if that doesn't work and you need to FOIL it and put it in a trinomial for big ideas, since this is new and this is a new book and a new unit, I'm not quite sure yet what form they're going to want, so we'll just have to work through it together. All right, so let's try the next one. Okay, again, you're going to want to rewrite it as a multiplication. So keep, change, flip. Keep the first fractional expression. All right, change to multiplication, flip the second. So we want the reciprocal of the second. All right, now we're going to start looking for some common factors. The numerator of the first one, I have a common factor of 5. In the denominator of the first one, I have a common factor of 2. The numerator between 14 and 20, the common factor is 2. And between 7 and 14, the common factor is 7. So I will factor all of those out. So I'll come down here. So factoring out of 5, I am left with m plus 2. Remember to factor, take 5m divided by 5 and 10 divided by 5. Factoring out of 2 in the denominator, I would be left with m minus 10. And then times, factoring out of 2, I'm left with 7m minus 10. No common factors between those two expressions. And then I'm factoring out of 7, and I'm left with m plus 2. All right, this minus sign didn't show up. Sorry about that. All right, so now remember, to get some common factors here, I have this expression m plus 2. Okay, the 2's, bing, bing. Any other common factors? Look at the 5 and the 7. Nope. M minus 10 and 7m minus 10. Nope. So now we're going to multiply. I have 5 times 7m minus 10 all over 7 times m minus 10. Okay, now if you distribute the 7, you get 7m minus 70. So, keep in mind, even though you think there might be some similarities there, there are not. Okay, and that would be our final answer. Okay. All right. Again, I probably should have looked before I started making the notes, but I will look after, and I will put it in the instructions if you need to simplify further, meaning distribute or, FOIL or things like that. We'll see exactly how they want their answers expressed. All right. So I'm going to pause, or you may want to pause and copy this down. I am going to scroll forward for the last example. Okay, this is example 5. Again, we want to put it in the right form, which is going to be keep, change, flip, and we will do the, so again, the second fraction that you're seeing, this 5x squared plus 5x over 1, you may not see the 1, right? It could just have the first fraction divided by the 5x squared plus 5x. So I've already taken the liberty of putting it over 1, so in case you see some of the work, make sure that you do that. All right, so that we will write the first one. Keep the first one, change to multiplication, and then take the reciprocal of the second. Okay, so we're going to factor the trinomial. We want factors in the first one in the numerator, factors of 2 that will sum to 3, so there'll be a positive 1 and a positive 2. X plus 1 times x plus 2. Again, you could always FOIL that. So keep the first one. We already changed the second. Now we're just going to factor the denominator. It's not a difference of 2 squares, but there is a common factor of 5x. So if I factor out a 5x, I'm left with an x plus a 1. Now I can cross-cancel some things, like I could cross-cancel the x plus 1 with the x plus 1. Ching, ching. Nothing else will cancel, so now I can go ahead and multiply x plus 2 times 1 all over 4x times 5x, which is 20x squared. Okay. Now, you can't cancel one of these x's with the x in the numerator because the x in the numerator is involved in an addition expression. It is not, the relationship is not through multiplication. You can only cancel things that are through multiplication. All right, so here's an example in the try it of division. We want to put this over 1. So anytime you have something that isn't already over 1 or over another denominator. So with we're going to put it in the form of multiplication. So 3x cubed divided by 2 times this 1 over the negative 15x to the 5th power. Okay, some common factors that we're going to have here are going to be the x's and the 3 and the 15. So for the 3, it goes into itself once, goes into the negative 15, 5. With x, remember you're going to do, there's 3 factors of x in the numerator, so it's kind of like here, like that, and in the denominator there's 5. So when you cancel out 3, you're left with 2 factors in the denominator because 3 minus 5 is equal to a negative 2. Those x's will be in the denominator. So multiplying across, I'll get the x's have canceled here and only 2 left. So we'll have, this will be equal to 1 over 10x squared, and don't forget that it's negative, right? The whole thing is negative because that was a negative 15. All right. Okay, so, that's the end of this lesson. If you have any questions, please be sure to ask for help. If there are any that are, on big ideas, take a screenshot and email it to me, or I guess that'd probably be the easiest, or set up a phone call before you start doing the problems. But I will give you 3 checks on big ideas. Alrighty.